everybody should be here. Welcome back. I hope you enjoyed your lunch break. And today we're going to talk about scalable vector graphics and the security impact on the modern web. I renamed the talk, to be honest, and I called it The Image That Called Me, and you will know soon why that actually happened. I think we can skip the introductory part because we had this yesterday already, so we can just head over to the talk and buy us some time. What are we going to talk about today? As the title indicates, we're going to talk about scalable vector graphics, about SVGs and the modern web, and especially the impact on the modern web and the impact on securities. We're going to learn what SVGs are, what they are capable of, which browsers currently support SVG, how they support it, in which ways SVGs can be deployed. We will see that there are kind of conflicted areas in SVG support. We will see what they are and what impact they have, and we will learn what all this has to do with actual web security or security overall, or even browser security. Let's talk about SVG images as general. Scalable vector graphics are a XML-based format. So if you have a look at the sources of an SVG image, you will see XML structures, most usually. Therefore, SVG images are very versatile. You can use them in many occasions for many purposes. They are accessible. It's basically, you can have a look in the source code. You can add metadata to comment several sections. Search engines can easily crawl SVG images, extract this metadata, so there's a lot of advantages. SVGs are even compressible. There is a kind of substandard which is called SVG-Z, which is basically a G-zipped SVG, and you can do some funny playthings with them as well. And most importantly, SVGs are stylable, so there is CSS you can apply on the elements inside an SVG graphic, and there is even a whole subset of separate CSS elements, CSS properties, and CSS values that are specifically available only for SVGs. Most of them is for typographic needs, like font kerning and other properties, filling brushes and stuff like that. SVGs are, of course, open. They are open source. You can just have a look into the sources, understand what the software creating the SVG or the author manually creating the SVG was thinking. And given all these facts, SVGs are as well great for mobile devices. SVGs were initially, or there is a whole SVG substandard only dedicated for mobile devices. We will learn about that later on. SVGs, given by the fact that they are XML and they have to be well-formed and valid, are easy to pass and easy to process. So it's not as complicated as this dirty HTML dialect or something like that, where you don't need quotes or don't need trailings or just valid structures. SVGs have to be valid and well-formed. The format itself is rather ancient. It's over 10 years old, actually. And we've been sitting on this format, and the browsers have been sitting on this format for 10 years as well. But so far, there was not real impact on the security of the WWW, of the World Wide Web, because one important fact was missing. We were going to see what this is. And SVG has relations to HTML5, or as they call it now, HTML, the living standard, where the recommendation or the standard draft is clearly recommending or urging browser vendors to support SVGs, to support them via image tags, via plugin tags, so such as embed, object, iframe, opening them directly, and even inline SVG. We're going to see later what this is going to be. Let's learn a little bit about SVG history. SVG was back then proposed by several W3C members in 1998. And it's a derivation from Adobe PostScript and from VML. Who of you here knows what VML is? Very good. VML, I would say, is a horrible dialect which was created back then by Microsoft, which was attempting to give HTML the possibility of displaying animations, of adding the factor of time, being able to say start with this and with this over a certain amount of time. If we have a little bit of time left after the slides, I have a nice example for VML, which is definitely proving why VML is extremely nasty. But basically, it was there and it was supposed to be an animation format. Some even call it, or a subset of it is called HTML plus time. Maybe some of you know it. Then there was, of course, Adobe PostScript. There was PGML, which was Precision Graphics Markup Language, and several companies submitted their proposals for the standardization to the W3C, and basically the W3C said, none of this is really perfect, so let's just take all these benefits, glue them all together, and create something new, and that basically was SVG. So it was developed in 1999, and it's currently in version 1.1, which is not very much if you think about the long time it had to last and to ripe. So one might think that not many things happened on the SVG playground. There is a version 1.2, but still a working draft, and the rumor has it that there won't be a release for 1.2, but it's rather going to be overtaken by SVG 2.0 in some months or even years. Meanwhile, we have very good browser support. We have Gecko, so all Firefox, Mozilla, and so on based browsers, which are natively supporting SVG. Firefox supported SVG initially with a release 1.5, so the support is quite mature meanwhile. WebKit was supporting SVG in a very early stage as well. Presto, the Opera layout engine, same thing. They even supported way more than necessary. We're going to see to what this leads later on. And meanwhile, we even have the benefit of Trident, the Microsoft Internet Explorer layout engine supporting SVG natively. And this was one of the main reasons why SVG didn't impact on the web at all, because Internet Explorer did not support it. You had to install a plugin from Adobe, and no one wants to install a plugin from Adobe. So it was very hard for end users to actually see SVGs, and there was installation necessary. So this was a pain in the arse, and developers couldn't just use it because there was no range or no sufficient penetration of the plugin. Here we have a very, very basic SVG example to just show off how simple the language itself is. It's basically a red dot. I doctored the shadow in there myself natively. It's not there, it's just to look better. You can see we have a starting SVG tag, which is applied with a namespace w3org/2000/SVG. Then we have a circle element, and the circle element isn't doing anything else than drawing a circle. We give it a radius. We don't use any units here. We just take radius 40, so whatever the device is actually using as a unit, it will be fine. Could be pixel, could be EM, whatever we need here. Then we apply the attribute fill, give it the attribute value red, and we have a red circle, and that's about it. That's how easy SVG is. There is a whole SVG family with several children, and I'm starting bottom up. The most comprehensive big brother of the SVG family is basically SVG full, supporting an overall array of 81 tags. I think HTML has about 99 with all of them combined, some proprietary ones, so you can see the complexity is not that far away from HTML tag-wise and attribute-wise. And 81 tags are quite a lot of stuff, and there's quite a lot of stuff you can do with them, like animations, transformations, effects, and so on. And SVG full is majorly designed for being used on desktop devices, on high computing power devices such as a good laptop, such as a desktop PC, or workstations for a graphics person or design person. Then we have SVG basic, also stuck at version number 1.1 right now, which is rather more designed for handhelds, tablets, and netbooks, so the not so strong machines and the not so large displays, which is very important here. And it just got 71 tags, and some stuff from the SVG full tag from the SVG full set has been omitted, which is some font-specific stuff. There are SVG fonts, of course, and I think there are some effects which are not working in SVG Basic 1.1. And then there is the black sheep in the family, like the dirty little brother, which is SVG Tiny 1.2. And this is a very nasty subset because there is so many special stuff in there. Like there is literally no real browser supporting SVG Tiny 1.2 but Opera. It's only got 47 tags, and some tags are completely different, like they do not appear in the other SVG standards, in the other SVG parts of the family. And it's majorly designed for cell phones and smartphones, so for devices very slow on computing power, very small displays and so on, but still to work on there. And when you have a deep look in the SVG Tiny specification, you will see a strong Java affinity. So there's a lot of interfaces connecting with Java classes and connected to applet-like behaviors and stuff you can use on the cell phone. And it's a little bit scary. And we will even see some examples to prove why SVG Tiny is a bit more scary than the other two SVG standards. Let's talk about some SVG features. What you already saw was geometrical shapes, like you can just draw a circle, but you can move on and be even more complex and creative, and you can draw an ellipse or a square or just a line and more. You can define paths, you can fill all this stuff, you can define gradients, you can even use SVG fonts. There was some funny bug in Opera back then with SVG fonts I'm going to tell you about later. An SVG font has a lot of benefits. You can just say, I don't use this proprietary and intransparent TTF or EOT or whatever font files anymore. I can have an open XML-based font where I can define every path for every character. I can define fallback character for Unicode characters I do not want to render or I can't render. You can fill them, and there was some funny discussion going on the Opera developer blog, I think, where they were discussing, would it be necessary to support iframes inside an SVG font, so a character can be filled with an iframe? And it was a short discussion, but they actually considered it, so there's funny stuff you can do with SVG fonts. There's a lot of font-specific formatting, there's glyph styles, there's kerning settings via CSS you can apply, and way more. But one of the most important features of SVG, in terms of thinking about them as images, is actually the possibility to apply them with links. So you can put an external link into an image. You can have an area which is clickable and leads you somewhere. You can even include stuff. You can say, hey, I'm a link, I'm just fetching something which I will display in the document later, which is quite scary in some situations. So you can see SVGs are definitely capable of doing way more than raster-based images, because they cannot use links unless you use one of these gruesome image maps from back then, like putting an image map around the defining zones, clickable areas, and so on. Who knows image maps? Or who still knows image maps? They are awesome. So SVGs support links. If they support HTTP links, they of course support JavaScript URIs and data URIs and more horrible things, but we're going to see this later on as well. SVGs also support animations and transformations. So you can say, hey, element, move from A to B over that amount of time, and transform during that time, start as a circle, end as an ellipse, and so on. There's funny things you can do. You can use gradients, you can use effects, you can have Gaussian blur, you can have transparency effects, you can multiply image data into each other, you can import raster-based images if you need the complexity. There is a whole plethora of effects you can apply. I think it's about 17 different effects you can use. You can look it up in the standard easily. I already mentioned the possibility to add metadata, which is giving SVGs the property of being very accessible, or potentially very accessible, of browsable. The search engine has way more fun browsing and parsing an SVG than a raster-based image. And I think most of you know the lack of quality of the Google image search. I do not want to bash it, because it's impossible to write a good image search unless there is a huge amount of tagging and metadata. So if you search for stuff in the Google image search, or in any given image search, you will find so many false alerts and so many false positives, or images you just cannot use, and which have nothing to do with the actual search term. And this is something SVGs can actually defeat, because you can put the info in there and make sure the images actually get found and get not being kind of interpreted by the surrounding markup or something like that, or the file name. But most importantly for this talk is the capability of SVGs to use scripting and events. So yes, we can just take a script tag and put it in an SVG, and it's going to be all right. We can say, hey, SVG, here is one element, which is our red circle, for example. Let's give it an almost over and turn it green on almost over. And all what you can do in the JavaScript DOM, or basically almost all you can do in the JavaScript DOM, or in the browser DOM, you can do with SVGs as well. They even have an own DOM, which is called the micro DOM in some situations, and some browsers actually apply SVGs with a different DOM than the actual browser DOM, but this is very much detailed already. And last but not least, with SVGs you can include almost arbitrary objects. So an SVG can very well contain an applet, and an SVG can very well contain a PDF or anything else, or a Flash file. So that's how flexible SVGs are. There is even a dedicated tag for including arbitrary objects, which is called foreign object. So whatever you put in this foreign object, as long as the browser understands it, it will be rendered inside the SVG. And this is quite interesting, and we're going to see later in the demo section why this is interesting. And this is also the reason why the talk is called how it's called. This, don't be afraid, is not a real tiger. This is one of the SVG demographics from back then. Originally, this legendary tiger was used to demonstrate the capabilities of GhostScript, if I remember correctly. And it became a kind of quasi-standard for just displaying the power of vector-based graphic languages or vector-based images. You can see you have gradients, you have a small amount of effects, you have paths and all that stuff. So this is one of the most well-known SVG demonstration pictures. I think it's ancient as well. It's from the early 2000s. Let's talk about SVGs and scripting. The following very simple SVG example will execute JavaScript. And, well, that's all. You don't have to do anything more. It's very simple. You just take the standard SVG tag, apply it with a namespace, take a script tag, put an alert1 in there, and then you have an alert1 as soon as you open the SVG in your browser. This is a very simple example. We heard you see some more quirky examples. I hope you can read it in the last rows. If not, just let me know. You see the very first example up there, it's using a G tag. Who of you can tell me what the G tag is? Does anyone know what the G tag is? We don't have it in HTML, it's only existing in SVG. No one? No one knows what the G tag is? So you see the G tag is being applied with an onload handler. So you might think that the G tag is actually loading something like an image tag. Image onload to something, body onload to something. Would it load anything? Actually no. The G tag is just a group tag. It's completely out of any capability of loading something or having visual impact. It's just a group element, just for internal document structure. But still it fires a load event. And this is indicating a very special feature of SVGs in many browsers. Any given tag, whatever you take, will fire a load event. So this can lead to a filter bypass in some situations. It's not very critical, but it can lead to a filter bypass. The next one, the example with the animation, is a little bit more interesting because here we can see again standard SVG tag, and in there we have the animation tag. And the animation tag is using the XML namespace xlang and then introducing the href attribute pointing to JavaScript URI. This snippet will execute JavaScript without user interaction. And we don't even need to define the namespace for xlang. This is happening automatically in the browser. As soon as the browser sees, hey, there is something prefixed with xlang, I'm just going to fetch the xlang namespace and it's going to be all right. And this is an actual filter bypass. This worked in many situations so far. Next example is similar. It's showing off the capabilities of the foreign object tag. You can also apply it with an xlang and the href attribute and again execute JavaScript without user interaction. And the fourth example, using set, is very evil. Have you ever heard of the set tag, or what the set tag is capable about? So I have no idea what the W3C was thinking back then, because this is completely nuts. Imagine a tag which is capable of changing other tags, specifically the surrounding tag. So you have a tag which is just meant to change everything around this tag. Like you could just write it in the document, but well, you can also do it with this tag. In this example, the set tag is influencing the SVG tag because it's surrounding it, and it's influencing the attribute onMouseOver. So there is no attribute onMouseOver, so the set tag is just giving the SVG tag, which is surrounding it, the attribute onMouseOver, and is setting it to alert 1. So if you hover the SVG, it's going to yield alert 1. You can even do this time-based and time-controlled, and you can use the animate tag for that. Now you can see in this very example, you don't have an event handler, you don't have an href, you don't have a JavaScript URI, you have two completely unknown attributes for most blacklist-based filters. One is called attribute name, only exists in SVG, and the next one is to. And these two attributes in combination generate the script execution. So this is quite nasty. On earlier Chrome versions, you could even influence the attribute onload and do it without user interaction, but with a smart onMouseOver, which is filling the whole page, you can just emulate no user interaction. And the last example, the fifth example, is actually showing off, or partly showing off the capabilities of tiny SVG and showing why it's a little bit weirder than the other ones. You can see again the standard SVG tag, which is surrounding the whole thing. And then we have a new tag, which is called handler. And this handler tag is being applied with a namespace introducing XML events. We're defining an event then. We're saying EV:event equals load. And then inside the handler tag, we just have JavaScript code. So the handler tag is the same thing, literally, in terms of a filter or for a filter. Or should be for a filter as a script tag. But it's called handler, and it's completely different. And this is working only on Opera, but on every Opera version I tested so far. Opera Mobile, Opera 11, Opera 10, whatever you want. And there are way more variations of exotic script execution you can do with Opera based on SVG Tiny. I'm not listing them here because it's just for an irrelevant market share of browsers, but you can see it's a bit quirky, and it's definitely fun to look into that stuff because there's way more. So now we might ask ourselves, why is this a problem at all? Like, we just have an SVG image lying around somewhere on some domain, and someone has to go there and click it. But it's not really exactly the truth. So there are several ways of actually deploying SVGs nowadays. We're going to talk about 5 of these ways. And the first one is the most simple one, but still affected with some security risks. It's just opening the file directly in your browser. Just finding an SVG link somewhere, click the link, open the SVG, done you are. The second one is the classic way, which was working for years in Internet Explorer, even with, in case this plugin was installed. It's just deploying an SVG in a plugin context, saying, hey, I just deployed with an object or an embed tag, or even an iframe tag, or the one you want to put here. This is not a very risk-effective way, and SVGs are not actually elevating any risk levels, because when you can inject an object tag or an embed tag in a website, you've won anyway, so SVGs are not making it any worse. And the third and more interesting way, the first way, which is way more interesting than the former ones, is deployment via image tag, and this is new. And this is the actual intersection SVG now has with HTML5, and the first way of making it a real problem on the web for current web security, because you can deploy SVG images with image tags. You might think, okay, image tags and SVGs can script, there must be something wrong, and there is something wrong. You can also use the image tag. I'm just calling it image to be able to distinguish a little bit better. Most browsers support both tags, so if you have a blacklist, make sure you don't only blacklist image, but also image, because it's practically doing the same thing. The fourth way of deploying SVGs is by using CSS. So you can use CSS backgrounds, you can use CSS list styles, you can use CSS content property on Opera and many other browsers. You can even use cursors, so you can assign an SVG cursor to your website. So you have some animated thing floating around when you point something on somewhere, which is a little bit nasty. There is another way of deploying SVGs, but I don't want to unveil it right now because it's quite funny, and there's also going to be a lolcat. And the fifth way is, in my opinion, the most critical one. It's inline SVG. And inline SVG was strongly urged by the W3C and the WWWG for HTML5 for browsers to support. So you can take any arbitrary web page, any HTML document, and just write some SVG code right in the middle of the document, like wherever you want, and it's going to render and it's going to work. So the parser is parsing the HTML and then jumping into the SVG context, then jumping out of the context again and rendering the rest of the page. And this is very, very interesting, and we're going to see some nice filter bypasses later on based on inline SVG. So, as you might think, when there are so many possibilities and so many new possibilities of deploying SVGs, there have to be some kind of security boundaries to limit the capabilities down, to say, based on the deployment, there must be kind of features available or not available. So what about if I have inline SVG, can I allow computing power intense effects? Or would that be taking care of DOSing the machine? Can I allow scripting via image-based or image-deployed SVGs? Can I allow this? Can I allow that? This is a little bit complicated. And the major problem here is that there is no specification or documentation on what browser vendors should actually do. We have on the one side the SVG specification, on the other side we have HTML5 saying, hey, just support it via image tag and inline, and it's going to be all right. But there is no document in the middle saying, hey, depending on how you deploy it, you should deploy it in that certain way and limit the features down or not. And this is actually giving us the chance to find a lot of new bugs and vulnerabilities, because the implementations of the browser vendors are accordingly inhomogeneous. So if there is no document saying this is how you have to do it, then every browser does it its own way. And when you test SVGs and how browsers react on that, you will see so many different behaviors and so many quirky ways of doing stuff. Every single browser does it differently, and it's quite interesting. So, one thing you can, of course, do is leverage XSS by using SVGs. And you might think, okay, image and image tag should never be able to execute JavaScript